Hey guys, Metal Stash here again, and today I am taking a little bit different direction on what part of my game I am developing. So today I'm going to be showing you guys what I've come up with for buildings because I've focused a lot on my units, so I decided to you know, change my direction a little bit and focus on another part of the game. Because I have my units coming along quite well, so let me show you guys what I've gotten so far. It's actually quite a bit. Let me let it maximize on play, and here we go. So I have a basic building here, nothing fancy, it's just a box to represent a building right now, and when I right click it sets a waypoint, or a rally point, whatever you want to call it. And then I have a new action that I've created called create spider. And when I create spider, I just clicked on it, it's going to add the spider to a build queue. It takes about 5 seconds for a spider to be created. So if I click another time, it's going to add it to the building queue, and then after about 5 seconds it creates another one and sends it towards the rally point. And if you set the rally point in a different direction, it also accounts for that. It also, if I go into the scene and not the game, if I have a building that is next to it, and I take, say, this one, set the rally point over here, create a unit, and wait a couple seconds, it won't spawn the unit between the buildings. It'll spawn it at a spawn point that is accessible for that size of unit. This is a lot to go over, so what I've changed in my building, or added to my building, excuse me, is I realized that a building and a unit aren't really that different. Buildings have actions just like units do. They have health and they can do damage and stuff like that. And so I actually just took the unit script, added it to the building script, and building just does a couple of different things that a unit does. So I kind of didn't have to do much more than that because there were a lot of things that I was going to have to copy if I was going to do like a whole separate class, which I really didn't need to do. So my building consists of bounds, which is an obstacle layer. So that's how I do my detections, which I'll show you in my scripts. Why does it keep asking every time? It has a selected plane and a waypoint. So there's not really much to a building object, but there's a lot that go into the scripts. So let me show you guys the scripts. So first I'll show you guys the create spider script. It's really simple, not much to it. It just takes a game object unit called unit, and on start I load it from the resources folder. Resources.load loads from the resources folder. So the way I had to get this to work is to create a folder called resources, and then I moved all my stuff into there so I could access all the prefabs that I wanted to, and I also moved all my prefabs into a prefabs folder so it didn't get meshes confused with prefabs. So then I just load it from the location that it's at and then its name. So then the last function, really not much. When the action is clicked, you guys know that function from before, then it gets the building component and adds the unit to the build queue. So it adds this unit to the build queue. So the important script is the building script, and this is attached to the building. It has a bunch of variables: waypoint, its bounds, possible spawn points obstacles, possible spawn points units, build queue, queue max, current queue, and current build time. So on start, I just store the waypoint game object for just you know, keepsake of I don't want to constantly keep accessing the same thing since it's always going to be there. So I just save it into the variable. It just saves a little bit of processing time. And then I call a function find possible spawn points given 4. Now what this does is it runs a search algorithm that I came up with that I'll actually show you guys by drawing it, because it's a lot easier to describe visually than it is by script. So you have this building here, and what I do is first start with the X divisions. Given that the width of the unit is 4, it's going to take it and start from this side, and it's going to divide by however amount it goes into it, and it's going to stop. It's an integer, so it only does whole number divisions, and so it's going to cut off that last bit of it. But what I do is I add 2 to it, so you get an extra 2 spots on it. So I start checking from these. I check doing a sphere cast. I do a check sphere actually at that point, and the unit's width divided by 2 because it's radius, not diameter. And I check against the obstacles layer. That's what my 9th layer is. So that's why I added this new bounds object to the building under the obstacles layer, so that if you had a building next to a building, it wouldn't try to create a spawn point there. So I get my X divisions here by just taking the collider's size and dividing by the unit width, and then I add that 2 there. Do the same with the Y, and then I just save its position, its bounds. I get the leftmost bound X value and the rightmost bound X value, and then I get the bottommost bound Z value and the topmost bound Z value. This is just for, it's a lot easier to code that out, because you see how much cleaner it is. You see bottom bound, top bound, stuff like that. And then I just have some the point that is to be saved array, because it, well, actually I don't need that now that I've changed my check sphere function. I don't actually need array, and then I have my array of points to be stored as my possible spawn points. So for every X division, that's going to search through every X division here. It's going to check, set the point value to that position where it left bound plus the unit width. So left bound gets this side. It gets all the way over here. This is the left. This is the left bound here. This is the right bound. So if its I is 0, it's not adding anything, and then it's going to take position dot y and subtract bounds divided by 2. So this just gets it to be away from the building by, or actually no, this is the what am I saying? This is the y value. Of course, I'm creating a vector here. So it's just getting the ground. It's taking the center position and subtracting the bounds divided by 2. So it's just basically getting the ground. And then I just take bottom bound and subtract 0.25. So that's the bottommost z value, and it subtracts 0.25 just as a buffer against the building. So then I check the sphere against that, and if it does not hit anything, that is an obstacles layer. That means it's a valid point to be spawned at. And I do that for, I start off at this one, then I go to this one, then this one, then this one, on and on, That was a terrible circle. Until I'm done searching the x values. So now I am going on to my y divisions. I check all my, wow, those are terrible boxes. And then of course I add extra 2 on the end of it, and that's just for a so you get the ends of it. And truthfully, you know, these overlap on the corners, but that really doesn't matter that much that they do, because, you know, then you're just checking it, you know, more than, you're just getting a better read on it, basically. Make sure you have a point to spawn at. So it's gonna check the left side first, so it checks this side, and that, and that, and that, and that. You guys get the idea. It goes from left to right and stuff like that. And then at the end, I store the points into the possible spawn points obstacles vector array. And I had to figure out how to store vector values really easily. So the way I did it is I created a JavaScript array which is just a new array. And in Unity, JavaScript arrays and built-in arrays are a little bit different. JavaScript arrays are very easy to change the size of, but they're not as quick. Built-in arrays are very quick, but you can't change the size of them as easily. So the way you can get around it is by just converting the JavaScript array to a built-in array, and then, you know, you just tell it that's a vector3 array, and it's fine with that. So I have my possible spawn points obstacles array. So now when I go into adding a new unit to the build queue, so when this function is called by create spider, so now I have my points that I can spawn at. I can actually show you guys what it does on startup, because I draw some debug arrays. So all these blue rays are possible spawn points that don't collide with the obstacles. So when I add a unit to the build queue, it does a couple of things here. But the important thing, or actually all it does, is check if the build queue is not null, and if it's not null, then it's going to set the build queue into a temporary queue, and then I'm going to add a unit to it as long as the current queue is less than queue max. So that's as long as the number of queued up units isn't greater than the maximum, which is 5 right now. And then I just store it back to the build queue, because I'm doing that, the JavaScript to built-in array trick, and then I add 1 to the current queue count. Otherwise the build queue is full, and you can see that in the debug. So in my update, I have, these are just my array drawings, so those aren't important right now. I have an update build time function that I call, and this update build time function says if the current queue is greater than 0, that means there are units to be queued up or to be built, then I'm going to add time to the current build time. And if that current build time is greater than the amount of time it takes to build the unit that is in the first slot of the queue, that's what it does here, then it's going to create that unit. And create unit, all it does, well, not all it does, because it does, this whole build script, it does a lot actually. I have a temporary unit, and I get the position of find closest spawn point given size 4. I'm going to change that later to the size of the unit, and I'm actually going to be storing those into separate arrays so that I don't have to keep calculating them. It calculates it on startup, and then it can do that very quickly. So it finds the closest spawn point given size 4. So what this does is this actually, it does the same type of thing as find possible spawn points function does, but it's going to try to find the closest one. So it's going to draw, let's see, where my paint go? So it's going to take, given the building again, big B, from the center, it takes for every spawn point, it draws an angle between that and your rally point that you have out here. And that is a terrible straight line, oh my god. And so it finds the angle between this, and if this angle is less than, like say this angle over here, then it's going to set this is a closer point than that point. So that's how it decides what the closest point is. I just do a couple of things here to do that. So going back to my create unit, so I get the closest point, and if the position returned is 0, that means it couldn't find a point to spawn at. There wasn't a possible point, so I just return and debug that, saying that unit couldn't be created. And so if it can be created, that means it's found a spawn point to create. I'm going to set temp unit to instantiate unit at the position at this rotation. So normally if you took unit and set it equal to that, you could do that. I tried that. But when I started creating a lot of units, testing the spamming of units, because I wanted to test that, how many units I could create, it gives it a name of unit parentheses clone close parentheses. And what it would do is once you start cloning a unit, it would create a clone of the clones, so you would have unit clone clone, unit clone 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 clone, and it would just be a ridiculous name of all these clones, over and over. So that's why I just created a temporary unit to get rid of that problem. So then I'd set the temporary unit's team to the player, or the buildings team, because the building's only going to create its own team and alliance units, so that's pretty easy to deal with. And then this is to get the unit to move towards the waypoint. So because I don't initially start with a move script on the unit, I need to wait for it to be created. So while its component move is null, I wait for the end of the frame. And then once it isn't null, that means it's been created or added to it. I tell it to move towards the waypoint, and it is not interruptible. That means it's on a move function. It can't attack until it's been done moving. So to check if, say you had a bunch of units around the building and raw X everywhere. These are units. That's like more of a star weird thing. So say you had a bunch of units around it, and this is because units move around. You have to kind of update which points are possible to spawn at. And so what I do is I actually search through all the possible spawn points against the obstacles, because the obstacles one isn't going to be updated as much as the units one, because obstacles, are either buildings, they're stationary type of things. They don't move, so I don't need to check them as much. But units I have to check every time I want to create a unit. So what I do is for each of the obstacles possible spawn points, I do another check sphere against those points, given the unit width against the unit layer. And if it doesn't collide with anything, I add it to this temporary array, and then again set it back to the possible spawn points units vector array. So that's where in my find closest spawn point function, I'm checking against my possible spawn points units vector array, because that's the array that's being updated with the possible points that you can spawn at. And possible is getting really annoying to say now because I've said it so many times. So kind of the last function that is added to this, because I know this looks all confusing, I need to add comments to this because I have not done that yet. And before I forget all of this, because I know I am going to forget this sooner or later, I need to add my comments to this. But my last function that really it's the build queue function, so that units act more like they're being created instead of if I take that out, it units can just be created instantaneously, and that's not really what you want. You want units to be created with time. So if the current queue is greater than 0, actually I've already gone over this function. I don't know what I'm talking about, or at least I don't know. No, I haven't gone over this function. What am I talking about? So I add time to the current build time. I think I might have gone over this a little bit. Oh, I know what I did. I moved off of this from create unit. So if the current build time is greater than the build time of the unit, I'm going to create a unit. I'm going to create another temporary queue array given this build queue, and I'm going to do a shift that removes the first element and then just basically shifts everything over one. So then I can just re-add that to as a built-in array and subtract one from the current queue and reset the current build time. So that's it, guys. I tried to go into it as much as I can to show you guys updating arrays. Don't use my tablet for that. So create a spider. You'll see here when the spider is created, these turn into green rays, and those are what I've defined as possible spawn points in the units array. So if I have another, if I have a unit sitting here and I try to create another unit, it's going to, it tells the array that these three are not possible spawn points because the spider's blocking those points. So that's about it, guys. I know that was a lot to go over, but it's a really cool thing that I finally gotten to do. The hardest part was truthfully getting the unit to move from the building and first instantiating the unit. The algorithm really wasn't that hard until once I just kind of sat down and got into it. So thank you guys for watching and listening again, and subscribe if you guys want to see more. I have like 11 subscribers now, so woohoo! And I'll see you guys later. Bye.